Today we're going to learn about independent and dependent variables. So first of all, if you know how to simply add 1 plus 1, which equals 2, you know how to find an independent or dependent variable. And what I mean by that is the following. For example, what does this problem equal? 3 plus something equals something. Obviously, we don't know what this answer equals yet. However, we do know something, that the solution, which I'm going to highlight in yellow, depends on the number that we add 3 by. So let's say, for example, that I filled out 3 plus 5 equals 8. The solution depended on the number that we added by. Let's try another one. 3 plus something equals something else. We don't know, but we do know something. That the solution, let me highlight that in yellow. Wrong color. The solution depends on the number that you add by. So let's say, for example, this time I added 3 plus 10. That is going to give me 13. The solution depended on the number that we changed. We first added 5, and then we changed it to 10. Let's look at another example. 3 plus something is going to equal some number. Again, the solution depends on the number that we add 3 by. Let's say this time we add 3 plus 30. 3 plus 30 equals 33. Every single time, the solution depended on the number we added by. This is where the independent and dependent variables come from. Think about the word independent and dependent variables. That word that they both have, the word variables. Well, the word variables means something that can be changed. So for example, when you have a variable, which is y, something that can be changed, x can be changed to whatever number, y can be changed to whatever number. A variable, a letter can be changed to whatever number that you wish to replace it by. And depending on what you change that, then your solution is affected by it. This is where independent and dependent variables come from. And independent variables is known as the one factor that is changed. So this is the variable that is constantly changed. So for example, above, we would change the number 5, the number 10, and the number 30. We were changing by what we were adding 3 by. Therefore, the number that you were adding was the independent variable. And sometimes this is noted as the letter X in algebra. And sometimes we can also note this as the predictor. So whatever you put for the independent variable is going to cause the dependent variable. Now the dependent variable is the factor being measured. The factor being measured. Just like over here in our solutions, we were measuring what was our final outcome going to be. What was going to be the solution? That is what we were measuring. This is always noted as the variable y in algebra, and we also know this as the outcome. So if you really think about it, independent is the cause. What are you changing? What's going on? What are you causing? And then what is the effect upon making that cause? So if we really think about it, we can even relate this back to ELA. You always have, weird looking square. You always have a cause, and then you have an effect, right? So we always have our cause, and then due to that cause, you end up with a specific effect. In math, it's the same situation, except this time we don't call it cause and effect. And you're right, we call it the independent variable. The independent variable, think about it as your cause. What is being changed, what's going on, and what happened as a cause, as an effect to the independent variable, as an effect to the cause. So let's go and take a look at a few examples and see if we can master finding the independent and dependent variable. We have Susie and Rita work at a small film studio and are planning a screening of their first feature-length film. The number of seats they will need to set up in the screening room depends on the number of people who attend the screening. We know that S is equal to the number of seats Susie and Rita will need to set up, and P is the number of people who attend the screening. So first of all, let's think about our independent variable and our dependent variable. Our independent is going to affect the dependent. Or another way that we can think about it is the cause is going to change the effect. What are you measuring? Well, we're comparing two things. The number of seats Susie and Rita will need to set up, and the number of people who attend the screening. Well, what is going to be the independent variable? Well, let's think about it. The independent variable is going to be the number of people who attend. That is the cause. So the number of people who attend, depending on the amount of people that show up, that is going to measure the amount of seats that Susie and Rita wanted to set up. So the effect in this case is the number of seats that they need to set up. So let's say, for example, only 10 people showed up to the screening. That means that then in that case, Susie and Rita don't need to set up too many seats. Let's say that they later on get a different number and they realize that, you know what, no, 50 people are going to show up. So then that's going to change the number of seats that they're going to set up. Let's say that in this case, they were like, you know what, no, 100 people are going to show up. Then that is going to cause for Susie and Rita to have to change the number of seats that they put. In this case, now we know that the number of people who attend is in fact the independent variable. Let's go ahead and write this down. The cause is your independent variable, and the effect is the dependent variable. So let's go ahead and see which one gives us this solution. So we have P is the independent variable. Well, let's look at what P is. The number of people who attend the screening. Well, let's check that out. The number of people who attend the screening. That is in fact P. And the dependent variable, the number of seats is set up. So it says S is the dependent variable. And S does stand for the number of seats Susie and Rita will need to set up. Therefore, this first option is our best answer. If you take a look at the second option, in this case, it's saying that S is the independent variable. S stands for the number of seats. However, we were able to determine that no, S, or the number of seats, is our dependent, which does not cause the amount of people that will show up. Okay, let's take a look at one more example. Again, I'm going to go ahead and set up my cause and effect. This variable will cause the dependent variable to change. So think about that. If I change this, will that affect the outcome? Will this predict the outcome? Let's take a look. Marshall is going to hang up clean shirts in the closet. The number of clean shirts to be hung up will determine the number of empty hangers that Marshall will need. So we're talking about Marshall. He's hanging up clothes. Depending on the number of clothes that he's going to hang up is how many hangers he will need. So what is the variable that we're changing? Let's go ahead and take a look at this again. I'm going to go ahead and write that this is my cause and my effect. So depending on what Marshall is doing, remember the cause is the independent variable and the effect is the dependent variable. So let's take a look at this. It's already given me the variables. It says S, the number of clean shirts. So depending on the number of clean shirts he has, let's say he has 10 clean shirts that day, maybe he has 5 clean shirts, maybe he has 2, maybe he has 30, we don't know. Remember that independent is something that can change. And then we have H, the number of empty hangers. So let's suppose that Marshall that day only has 5 clean shirts. Then that will cause him to only need 5 hangers. Let's say he has 10 clean shirts. Then obviously he's going to need 10 hangers. What if he has 100 clean shirts? He's going to need 100 hangers. So if you think about it in that perspective, we are able to see that the cause is in fact the number of shirts. Let me write that down. The number of clean shirts, which is also represented by the variable S. So I'm going to put S here. This is my cause. The number of clean shirts is going to cause, or is going to change the effect of how many hangers he will need. So then for my effect is the number of empty hangers, which in this case is represented by the variable H. So I'm going to put H here, H for hangers. So we know that the number of clean shirts is independent and the number of empty hangers is dependent. So let's go ahead and take a look at that. It says H is the independent variable. Well, let's look at what H is. H is empty hangers, and we were able to determine that no, that's my dependent. Therefore, this is not the correct answer because it has the wrong variable. Next one. S is the independent variable, correct? And H, the number of hangers, is the dependent variable. This is correct. So if you think about it, the number of hangers that he's going to need depends, it's depending on something. Depends on the number of clean shirts that he has for that day. So let's say, for example, and let's draw a quick table. Got my, it's independent, it always goes in the first column, which in this case is S, the number of shirts, and H, the number of empty hangers. Let's say he has 1 clean shirt. He's going to need 1 hanger. How about if he has 3? He's going to need 3 hangers. How about if he has 10? He's going to need 10 hangers. What if he has 100? And he's going to need 100 hangers. So if you notice, this cause is changing. This cause will always affect the dependent variable. Okay? And that is our lesson for today. I hope you are able to finish your practice assignments. Don't forget that you have Khan Academy and you also have a new assignment on quizzes. Have a great day.